Now I'd like to look at some graphing examples. So what I'd like to do here is graph f of x and g of x. And what I like to do sometimes here is actually create a table to help gain some perspective on what's going on here. And when I'm doing parabolas, my default points that I like to plug in are -2, -1, 0, 1, and 2. So if plugging that into f of x, well, it's -2 goes in here, and that means -2 squared, or -2 times -2. Well, a negative times a negative is a positive, and 2 times 2 is 4. Same thing here, -1 squared. Well, -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. So if we go over and we plot that over here, we go over the -2, and we go up to 4. Go to 1, -1, 1. Go to 1, 1, and then 2, 4 again. And you can see that this is plotting the graph of a parabola. And I want to label the vertex at 0, 0. And this is f of x is equal to x squared. So let's take a look at doing those same points for g of x and see how that works out for us. Plug in -2, -1, 0, 1, 2. So if I plug in -2, I get -2 plus 4, which is positive 2. 2 squared is 4. 4 times -2 is -8, plus 6, or plus 2 is -6. So I know I'm going fast there, but if you plug these points in and check them out, you'll find it's the same thing. So if I plug in -1 here, then I get 3. 3 squared is 9. 9 times -2 is -18, plus 2 is -16. Plug in 0, I get 4. 4 squared is 16, times 2 is -32, plus 2 is -30. If I plug in 1, I get 5 squared, which is 25, times -2, which is -50, plus 2 is -48. I plug in 2, I get 6. 6 times 6 is 36, times the -2 is -72, plus 2 is -70. If you try to compare what we have here in f of x and g of x, I can't plot this particular graph with the points I have on the Cartesian plane I have. So I've got to pick different points. And so before we do, let's review a couple tricks here. First off, let's find out what the h, a, and k values are for f of x. A is 1, h is 0, and k is 0. Let's do the same thing for g of x. Well, a is -2 here, h is -4, and k is 2. Oops. So the vertex is actually 4 units over and 2 units up. So the vertex is right here. Oops, right here. And so I'm going to label that at -4, 2. And we know that this graph is going to point downwards because the a is negative. Maybe if I pick some points right next to the vertex, I might get better values for the y that'll be more realistic to graph. So let's go 1 unit to the left of -4, and that will be -5. So we'll try that in the graph. So -5 plus 4 is -1. -1 squared is 1. 1 times -2 is -2, plus 2 is 0. So I've got a point that I can plot right here at -5, 0. Let's go 1 unit to on the other side, which is -3. So if x is -3, then I've got -3 plus 4, which is positive 1. 1 squared is 1, times -2 is -2, plus 2 is 0. So I've got a point plotted over on this side. Now let's try one more on either end. So we're going to try -6. And then if we go 1 unit over this way, we'll go and try -2 next. So -6 plus 4 is -2. -2 squared is 4. 4 times -2 is -8, plus 2 is back to -6. And -2, well, we've already actually done it right up here, but we'll do it again. -2 plus 4 is positive 2. 2 squared is 4. 4 times -2 is -8, plus 2 is -6. So what we have is 2 more points here. So if I go over to -6 and I go down 6 units, which would be 1, 2, 3, 4, 5, 6, come over, be plotted about right there. If I go to -2 and -6, be plotted right about there. So if I draw this graph in, what you might notice, and my drawing's not going to be perfect here, is that this graph is skinnier because it's been stretched by a factor of 2, and it's upside down because it's negative, and the vertex has moved over 4 units and up 2 units. So one of the keys that I had to do here is I didn't want to pick necessarily, if I wanted to plot this, I didn't always want to pick -2 to 2 for the g of x because it could really be off the charts. So when we go and graph the next one, what we might want to do is we want to first graph the vertex for g of x, then go and pick data points. So let's take a look here at example 20. With example 20, first we know the parent function, and if I use the table up above, instead of just going through the data points again, we'll just copy it down here so we have a comparison. We've got -2, -1, 0, 1, 2, and that would be 4, 1, 0, 1, 4. I plot those points. Oops. So I've got my parabola coming up here. Okay, poorly drawn, of course. We'll label that as f of x is equal to x squared. Now for my g of x, let's identify the a, h, and k here. A is -0.3, h is 0, and k is 2. So what does that tell me is the vertex is actually right here at 0, 2. So I've got it plotted, and I'll label it 0, 2. And now this graph actually is going to be flipped upside down, but also going to be wider or stretched. And it looks like since the vertex is at 0, 2, picking points to the left and right, I'll be picking the same kind of points I have for g of x. So in this case, it's okay to pick -2, 0, or sorry, -2, -1, 0, 1, and 2. But we're going to get uniquely different answers here. So if I plug in -2, I get -2 squared, which is 4. 4 times 0.3 is going to give me 1.2, and it's negative. Oops. And then plus 2 is going to give me a positive 0.8. So 1 squared is 1 times -0.3 gives me -0.3 plus 2 gives me a positive 1.7. If I plug in 0, I get 2 out. If I plug in 1, well, I'm going to get that 1.7 again. And if I plug in 2, I'm going to get 0.8 out. So let's go plot these. So I go over to -2, and I go up to 0.8, which is going to be just about right there, and I have to do my best to estimate it. If I go over to -1, I go to 1.7, which is going to be right about there. And if I've got 0, 2 plotted, now I come over here and I go to 1 and 1.7, which is going to be about right there. And let's try that again. It didn't really show up. And then if I go over to 2, I get to 0.8. And so this thing gets much wider. As you can see, it's just going to be a wider graph. And what I'm looking for you is to have a couple points plotted. The plotted points down here wouldn't be perfectly matched up with what I graphed, but I want the general idea that you know how to make a graph wider or compress it, flip it, move it left and right as needed. So we'll label this as g of x is equal to -0.3 x squared plus 2, and we'll call it good at that. So let's take a look at, oh geez, oh Pete. So let's take a look at the challenge problems, and I would like to work with you on problem number 3, picked randomly. And what we want to do here is find an equation of the parabola we have here. And step 1 is find the vertex. So the vertex here is going to be at, looks like -3, -4. Oops, I'm going to change pens here. So vertex at -3, 4. And with that, I can actually start filling in some of the vertex form of the equation. I don't know what A is, and it's going to be x minus a negative 3 or x plus 3 squared minus 4. Step 2 is pick a point. And any point on the graph to plug in, because what we're going to do is solve for A. So pick a point and look for something that hits the graph nicely. So if you found one that looks nice, I can tell you that the first thing I'm going to do is look over and up until I find something, and it looks like right here the graph hits the point negative 2 comma 3. So negative 2 comma 3 is the point I'm going to pick. And what I need to do now is actually plug it into the equation and solve for A, because that will be the only unknown that I'll have left. And I'm plugging in negative 2 comma 3. So then I've got, well, where I see f of x, that's the y value, so I get 3 is equal to A times x is negative 2 plus 3 squared minus 4. So let's do what's inside the parentheses first, and I get A times 1 squared minus negative 4, so 1 squared is 1. So now I've got 3 is equal to A minus 4. I add 4 to both sides. Oops. 4 to both sides, and I get 7 is equal to A. So now I have my A value, and I have the completed function, so I'll rewrite that in red to make it stick out. So I've got f of x is equal to 7, which is my A value, times the parenthesis x plus 3, close parenthesis squared minus 4. So that's how you do it. You find the vertex, you plug it into the standard form, then you pick another point that is nice on the grid line, and you plug that in, you solve for A, and you get the function. Now in number 4, I know it looks kind of weird. Just draw in the rest of the parabola. You have the vertex. Look for a point where it crosses nicely. It looks like at 0, 2 is a perfect spot. You plug those things and you'll find an equation of the line. And you do so for problems 1 and 2.